Hello everyone, welcome to the live class. So guys, today we are having another very important session in which we will discuss many questions, and I hope that after the discussion about the questions related to the topic, that is Hamiltonian dynamics, all the concepts related to this topic will get clear to all of you. And if there will be any doubt at any point you will have, you can let me know about it, and we will try to consider all those points as well along with the discussion. So I hope after attending this session till the end, you will have a very clear idea about all these points which we are going to consider in today's session. So let's quickly start the discussion. Bhavneet, it's Monday, Tuesday, Wednesday. At 4 o'clock, we will have the Unacademy live CSIR UGC net YouTube channel. Okay, so are you all ready for the discussion, and can I give you some of the questions related to the concepts and the topics we have discussed till now related to Hamiltonian dynamics part. Okay, so let's consider all these questions so that you will be able to know what type of questions you can expect in upcoming exam, what are the points related to which questions can be there, and every point will get clear. Okay, so let's consider the questions. Just a second, I'm going to give you your first question of today's session. This is performed. Options I'm going to note down on the next slide. I will show you the previous one once again. Try it once and let me know as you will get the answer. And if there will be any doubt or difficulty in getting the answer, don't worry, I will start the discussion. And guys, don't answer just without solving it. Please solve it first and then finalize your answer so that you will not make any mistake anywhere. Very good Riya, very good Sudha, very good Papneet, very good Kirti. Ramchandra will consider it. Clear? Like I have told you about the action part. What is action? That is the time integral of Lagrangian. I have even considered it in the previous class. So if you are just considering that action phenomena, we consider it related to Lagrangian. And you know, if something is related to Lagrangian, okay, you know the relation between Lagrangian and Hamiltonian both. So you can even convert those formulae. Clear? So both the phenomena you can easily relate and you can get the expression related to whatever point they have asked you. And mainly related to action, whatever question we get now, that's gonna be that in which they will clearly tell you that, oh, okay, use the action phenomena and then just find it. Or the given parameters. Depending on that, you can easily finalize that, oh, action you have to use or you have to consider. Pradeep question is here. Very good Akshay, very good Vandana. Harinder, in the last two classes related to classical mechanics, Lagrangian dynamics, Hamiltonian dynamics and all their formulae I have discussed. So today, now we are going to practice questions based on them. Very good Payal, very good Seema, very good Deepika, very good Mali, very good Neetu. Very good Ramchand. Okay, so let me know, is there any doubt anybody is having in this question or is it clear to everyone? Any doubt or is this clear? Okay, SK saying option C. Okay, Harinder. So guys, yeah, right answer will be option B. If anybody is getting anything else except option B, then we need to discuss it. Clear? So guys, let's talk about it. First of all, let's consider the steps we have to take to solve this question. But how we will get to know about those steps? So let's consider the question first and then observe what are the things given to you in the question and what you want to find. So a canonical transformation, this is the canonical transformation which is taking place, is performed on the Hamiltonian. This is the Hamiltonian given to you corresponding to old set of coordinates via the generating function. This is the generating function. Okay, if q0 is equal to 0, that means when t is equal to 0, the value of q is also 0. This is the kind of boundary condition given to you. Clear? Which of the following graphs show the symmetrically the dependence on qt of qt on t? Okay, that's what we need to find. The point is they have mentioned capital Q here. Okay, now the point is that firstly I need to get the relation between the Q, capital Q and T, and then I can draw the graph. Then I can finalize, oh, this is the graph. And how I can relate the coordinate Q with time T. So for that I need to think like, oh, I will relate this first, then this thing, and that's how I can get the relation. Basically Hamiltonian which is given, that's corresponding to old set of coordinates, small p and small q. If I will get the Hamiltonian corresponding to new set of coordinates, that's capital P and capital Q, then I will easily be able to write the Hamilton's equation of motion corresponding to that. The Hamilton's equation of motion is q dot is equal to del s dash upon del p. What is this q dot? Q dot means del dq upon dt. Okay, you can write q dot as dq upon dt, and s dash, that is the Hamiltonian corresponding to capital P and capital Q. So what you can do, firstly get the Hamiltonian corresponding to new set of coordinates, then take this step and you can finalize which option is correct. Very good, Anirban. Now let me know, is the approach clear? That what approach or what steps we will take. Firstly we will find the new coordinates corresponding Hamiltonian expression, then we will use the Hamilton's equation of motion for that, and that's how we'll get the relation between Q and T. Okay, so let's find the Hamiltonian first. We know what is the relation between the new Hamiltonian and the old Hamiltonian, that is H dash is equal to H plus delta F upon delta T. Is the F function of time here? No, it's not a function of time. So the partial differentiation of F with respect to time will be what? That will be 0. So okay, we are just going to get H dash is equal to H, because F is not a function of time. So that will be 0 and we are getting this. But the point is, H is already just in terms of old set of coordinates, small p and small q. So let's write it first. P square upon 2m, p square upon 2m plus, it's the another expression is half m omega square q square, half m omega square q square. Done. Next thing, now this cannot be the new Hamiltonian. Why? Because it is in terms of old set of coordinates. So by using the given generating function, what is that? That is half m omega q square cot q, half m omega q square cot q. By using it, I will find the expressions or the values of small p and small q in terms of capital Q and capital P. Now when you are observing this function, it is a function of which coordinates? Small q and capital Q. So what is not present here? Small p is not present, as well as capital P is not present here. If you have attended the last 2 classes in which I have done the discussion about classical mechanics, you will be familiar with these things, that how we write the formulae. So small p formula will be what? That's going to be delta F upon delta small q. And what about capital P? That's minus delta F upon delta capital Q. In the last 2 classes, I've cleared it very well, that how you will memorize the formulae and how you are going to write them. So that's what we are following right now. If I'm going to solve this expression, I will get m omega q cot q after differentiating the generating function with respect to small q. When I'm going to differentiate the generating function with respect to capital Q, what will be the expression or the differentiation if you will do for the cot q with respect to q? What you will get? What is the differentiation of cot q with respect to q? That's gonna be cosec square q, that's with negative sign. Okay, so it's gonna be minus half m omega q square and minus cosec square q. Okay, now minus minus will become plus. So that's how you are getting the value of capital P. Clear? Now, if I'm going to solve it a little more, I will get the expressions of small p in terms of capital Q and capital P. I want that. Why? Because I have to put the values here to convert it as a Hamiltonian for the new set of coordinates. So if I'm going to consider it, what are the values we can get? If I'm going to talk about the value m omega q cot q, okay, cot capital Q. So it's going to be here m omega q and cosec square q is present here. So what I can do, I can, let me just tell you what we can do to simplify it. We can do one thing, that either get the value of small q from here, or what we can do, we can put the value from here. If we will get, okay, this is easy for us to find the small q value in terms of capital Q and capital P. So let's try to find it out. Small q will be equal to what? P upon cosec square q and m omega. Done. And 2 will be here. That's what we are getting. This is the value of q square. So if you want to write the q value, what you will get? It will give you q is equal to root 2p upon m omega and sine q. That's what you are getting. Once you have got the value of this small q, put it here back in this expression to get the value of small p in terms of capital Q and capital P. What you will get from here? You will get m omega. What is the small q value? That's square root 2 capital P upon m omega and sine q, and cot q is written here. Cot q means what? Cos q upon sine q. Sine q cancelled out, cos q you are getting there. It's going to be root 2p m omega into cos q. That's what you are going to get. Okay, you have got the value of a small p, you have got the value of a small q in terms of capital P and capital Q. Now your next step is put these values in this expression of Hamiltonian. Let's put it here. What we will get? H dash is equal to, small p is root 2p m omega. That's in square root. So when I am going to just do its square, m and m will get cancelled out, 2 and 2 will get cancelled out. So I will just get p omega and cos square q. Okay, p omega, oh that's in capitals. Is that capital letter? Yes, p omega and cos square q. Clear? Next thing, if I am going to put the value of q square here, like q already we know, if you will put it, what will get cancelled out? M will get cancelled out, also 1 omega will get cancelled out. So we are just going to get, also 2 will get cancelled out. So what we will get? We are going to get p upon omega and sine square q. Okay, p upon omega. Is that p upon omega you are getting? No. It's just p omega sine square q you will get. P omega sine square q. So that means you are going to get p omega cos square q plus sine square q is what? That's going to be 1. So new Hamiltonian is just equal to p omega. That's how we have got it. If there is any doubt anybody is having till this point, you can let me know. Okay, and if it is clear, that's good. Now our target is to know about the value of q in terms of t. So we know the Hamilton's equation of motion, q dot is equal to del h dash upon del p. Why I am writing it h dash here? Because the new Hamiltonian I am denoting with h dash. Okay, so it will give us dq upon dt is equal to p, when I am going to put p omega here and I will differentiate it, d upon dp of p omega. Okay, then what I will get? I am going to get here that's equal to omega only. So dq will be integration omega dt. Okay, integration omega dt, and let's say we will take a integrating constant on one of the sides. So I am going to get omega t plus c. Now the point is, this is the equation of a straight line. But the point is to finalize our answer, whether option A will be correct or option B will be correct, we need to consider that what is the value of the constant term c, because c will tell you about the intercept on the y-axis. Clear? That means qt axis in this case. So they have provided you one boundary condition, that is q0 is equal to 0. That means at t is equal to 0, the value of q is also 0. So when I am applying this boundary condition, q0 is equal to 0, what I will get? 0 is equal to 0 plus c. So I am going to get c is equal to 0, which is going to show us that q is equal to omega t. What it means? It means the intercept on the vertical axis, that is 0. There is no intercept. So what is going to be the right answer? That will be option B. That's how you can easily finalize that which of the given options are correct, and that's how you will be able to consider it. Is this clear to everyone? All the steps and everything now? That what steps we are taking? And this was a previous year question. Okay, I have made some changes in the options a little bit. Otherwise, if you have already solved it, you may get the right option easily. So right now I have just made some changes. Otherwise the options were quite easy which were given to you. It becomes very easy to select the answer. Okay, clear. That's good. Can we consider the next question? Can we consider the next question? Done? Okay, if you will have any doubt anywhere, you can let me know about it. Guys, I hope the voice, slides, audio, video, like everything should be fine. And if there is any issue, like if everybody will be facing the same, that means yeah, there is some issue. But if not everyone is facing that issue, you can rejoin the session. I hope it will even get okay for you. Your next question is here. You can start solving it. This is one. And there will be different type of questions which we will consider, because they are going to be mostly from previous years CSIR net physics exam. So you will get to know about all these different type of questions which you can expect in the exam. Try it and let me know which option is correct according to you. Shirun, SK, guys, some of the students have mentioned some points regarding the previous question. So I'm going to consider their doubts and then we will come back to this question. I will consider your options too. Very good Riya, very good Ramchandra, very good Seema. Till now 3 answers are there. All are different. Option B, option A and option C. Okay, I've got, but we will finalize it which option is correct in this one. Till then I'm going to clear the doubts regarding the previous question. So SK, you have mentioned y h dash is equal to h. SK, have a look at the given generating function. This is given in the question. Okay. If you are going to find the del f over del t, that means the partial differentiation of generating function with respect to time. Is there t present somewhere? No. So what will be the value you will get? It's gonna be 0. Okay. So when it is 0, what you will get? You will get h dash is equal to h. And that's how the h dash and h are equal. Okay. But you can't say this h dash exactly is same as h in terms of small p and small q. That will not be right. With the generating functions, we are having these formulae like 2 I have used here. So by using these formulae, you have to get the relation between the old set of coordinates and the new set of coordinates. And finally, you will put those values and get the final expression of new Hamiltonian. Okay. So I hope SK, that doubt is clear to you that y h dash is equal to h. Okay. With the formula we have considered it. Now next, Shirun has considered in actual what we want to find out. Shirun, we want to find the relation between qt and t. If you are having some graph given to you and you want to locate the points on that graph, okay, you want to draw it, you want to make that graph, what do you need? You want the relation between those two parameters. So we were focusing on getting the relation between the q and the t. Okay, and for that I have told you the approach in the starting, that firstly we will find the Hamiltonian corresponding to new set of coordinates. Why? Because the capital Q is here. So for that we need the new Hamiltonian corresponding to new set of coordinates. So that's what we have found out first. And second step, I have told you that you have to use the Hamilton's equation of motion, which is q dot is equal to delta h dash upon delta p. where S dash will be the Hamiltonian corresponding to new set of coordinates. So this approach which we have discussed in the starting, before starting the solution, that's what we are following and that's what we are actually going to find. Okay, and after finding it out, we will just get the final solution. And any other doubt, any other doubt? Kirti, most probably it will be there at the same time, because after this class at 5:30 I'm having the plus course class, so that will be 5:30 to 7 o'clock, and after that around 7:20 we can have that session done. So yes, it will be there. And any other doubt? I hope no doubt. Okay. Bhavneet, option D, I'm going to show you all the options. The options are here. Option D is not clear. Let me just check. That is 1 upon 2m px square. I'm going to write it once again here. Minus 1 upon 2m px square. Done. Now, very good Shirun, very good Anirban, very good Vandana, very good Akshay, very good Sayada, very good. नहीं, प्रदीप आज स्पेशल क्लास नहीं है. Very good Sunil, very good Kirti, very good Bhavneet, very good Harinder, very good Ananya, very good Asha, very good Devajani, very good Subramanyam, very good Saddam, very good Mali, very good Pooja, very good Deepika, very good Krishna. So guys, basically option C will be correct. Okay, but if you are not getting option C, let me know. Very good Sudha, very good SK. Anirban, it may not be there today, but in Newtonian dynamics, basically guys, what we are having in Newtonian dynamics, like every basic part of classical mechanics. Okay, that's what we are having. We'll try to consider it soon. Okay, but today it may not be there. Done, but we will soon try to consider it. No Vandana, आज special class चाहिए. Very good Pradeep, very good Archana. Now let me know, everybody is getting option C, or do you want me to discuss it? Everybody is getting option C, or any doubt is there anybody is having and you want me to discuss it once? Because option C will be correct. Now if you are not getting it, if it is not clear, we can consider it. Let me know. Is this clear to everyone? You want me to discuss? Okay, let's talk about it then. Basically guys, in this question the Lagrangian is given and we want to find the Hamiltonian. A very nice question it is. Now if Lagrangian is half mx dot square plus mx dot y dot and you want to find the Hamiltonian, so you know the relation between both. H will be equal to summation over I qi dot pi minus L. How many coordinates are involved here? 2. X and y. So we'll write it like x dot px plus y dot py minus half m x dot square and minus m x dot y dot. We are just putting the Lagrangian expression here. Is this your final answer of Hamiltonian? No, it cannot be the final answer. Why it cannot be the final answer? Because we know that Hamiltonian is just gonna be a function of generalized coordinate and momentum. But here the generalized velocity is even present and our target will be to remove these generalized velocity terms from here. Even if you are observing the options, in the options you are just having the px, py and the mass present. So let's try to consider it. Now how you can remove this thing? You know there is a relation between generalized momentum and generalized velocity related to Lagrangian. That relation is this one. I can even just write in general q dot here because corresponding to x dot and y dot we'll write the separate expressions. So if I want to write px, I will say, oh, it's gonna be equal to del L over del x dot. If I want to write py, I will say it's gonna be del L over del y dot. What is gonna be the expression or the value I will get after solving del L over del x dot? So I am going to get mx dot plus my dot. Okay, that's the value of px. And if I'm going to find py, what I will get? I will just get mx dot. So mx dot is equal to py. So what will be the value of y dot from here? If I'm going to put this equal to what? Py. So I will get px minus py upon m, that is the value of y dot. I will put this value in places of y dot here, here and everywhere wherever the y dot is present. And also what is the value of x dot I will get, because I need to replace that too. I will get py by m. So x dot is equal to py by m. So x dot is here, py by m, py by m. Put it all the values you have got from x dot and y dot. Let's consider them. It's going to be h is equal to x dot is what? Py by m, py in upon m upon into px. Okay, it's already present here. We have simplified this part. Then y dot. What is y dot? Px upon m minus py by m. So let's consider it in this way. Px into py upon m, okay, minus, it's plus and minus py square upon m. Okay, just put the values and minus half m x dot square. So it's gonna be py square upon m square. One m will get cancelled out, so we'll get half py square upon m. Okay, minus py square upon 2m. Clear? Py square upon 2m. Next, last term, that's m x dot y dot. So for simplifying it, let's put the values first and then we will just multiply. So py upon m for x dot into y dot. What is y dot? Y dot is px minus py upon m. Px minus py upon m. Let's simplify a little more. What we will get then? Px into py upon m, just simplification. Oh, px into py upon m 2 times. Okay, add. Guys, done. It's py just. We will simplify it a little more, but till then we have just written it like this: minus py square upon m. Okay, let me know. Minus. Is it sign like same sign we have considered? Minus half m x dot square. Okay, py square upon m square, py square upon 2m. How we are going to consider it? 2 was present here, right? Y dot is px minus py minus. That same sign will remain there. Done. Py square upon m, right? Take it. Okay, py square, that's gonna be minus 3 by 2 py square upon m. Okay, because minus will be plus. Let's simplify further. So we are going to get px py upon m plus py square upon m. So in this way, what you will get? 3 by 2 minus 1. You will just get 1 by 2 back. So it's, and 2 minus 1. It's going to be px py upon m. Okay. And minus 1 upon 2 py square upon m. That's going to be our final answer. Let's check the expression. Px py upon m. Oh, it's here. Px py upon m. Minus 1 upon 2m py square. Minus 1 upon 2m py square. That's going to be option C. Is this clear to everyone? Pooja, it can be in any part. Both, like even if it is in part B or it is in part C. If it is in part B, we are getting 3.5 marks. A good weightage. If it is in part C, we are getting 5 marks. A very good weightage. But we can't even miss whether if it is in 3.5 marks or in 5 marks. We want both. Done. So in any of the sections it will be. That's okay. Our target is to do maximum number of questions correct in the exam. Okay, and our focus should be on the concepts. Okay, and then after that, in whatever section we are getting the questions, that's something they will decide. This time they can give you this question in any of the parts. Earlier in what part, what section they have given, that was a different thing. Some of the topics in the syllabus, okay, that is the official syllabus, some of the topics are also in part B as well as in part C. That means they are having the chances to be in any of the parts, okay, or the sections in our question paper. So don't worry about those things, because when you start thinking in this manner now, you take one extra thing in your mind. Clear? which is not at all required. Your target should be do the best preparation as well as to know the concepts very well. Now whether it's part B, part A or part C, it's okay, because every question is going to give you some marks. So that should be your target, to achieve them from whatever section you can achieve. Done. SK, we can't solve it by using the short trick. Why? I have told you short trick will be applicable when you can separate the kinetic energy and the potential energy terms. So here it may not be possible for you to identify them exactly. Also here you are going to have this thing. Clear? You can't compare it with half mv square form. So it may be a little bit difficult task for you to relate it. So I would say it's better to consider the detailed method for this question, because in that short trick we consider that we compare half mv square and then we just find the value of m and then we put it as p square upon 2m in the Hamiltonian part. So that's what we do. Okay, so I would suggest in this type of situation when it's not exactly comparable, you will try to go for the detailed method. That's the best thing. Ramchandra, that's thermodynamics and statistical physics class, but that is a plus course class today. Okay, 90-minute session will be there. So it's gonna be from 5:30 to 7 o'clock, and that's thermodynamics and statistical physics session. Clear? Mali, in some of the sessions I will provide you the syllabus as well, or you can you can even directly check it on the NTA UGC net, or you can say directly CSIR UGC net. Okay, that site you can directly find the official syllabus. During the sessions even I consider it, but in the starting when we start the discussion. Is this clear to everyone? Can I consider the next question? And guys, all the questions I've considered till now, even I'm considering right now, they are from the previous year's CSIR net physics exam. Please try it once and let me know as you will get the answer. Harinder, for the practice, see, once you complete any topic, then take or consider the previous year questions based on that. ठीक है, मतलब जब आपने कोई टॉपिक कंप्लीट कर लिया या आपको पता है उसमें कौन कौन से किस किस टाइप के क्वेश्चंस आते हैं, क्या क्या चाहिए उस टॉपिक को पढ़ने के लिए, या मतलब किस टाइप से पढ़ना है, उसको कंप्लीट करने के बाद में, उसके फॉर्मूले पता करने के बाद में, कॉन्सेप्ट्स पता करने के बाद में, you can go for the previous year questions. Clear? Now you can start solving the previous year questions first from the CSIR Net Physics exam, and after completing them, जब आपके CSIR Net Physics exam के मतलब इस तरह से करते करते सारे सब्जेक्ट्स कंप्लीट हो जाएं, ठीक है, उसके बाद में जब सारे सब्जेक्ट CSIR Net Physics exam के previous year questions के थ्रू कंप्लीट हो गए, उनकी प्रैक्टिस भी हो गई, तब आप गेट फिजिक्स एग्जाम के क्वेश्चंस की प्रैक्टिस शुरू कर सकते हैं. और इसी तरह से देन सम अदर एक्स्ट्रा प्रैक्टिस क्वेश्चंस, बट सबसे पहले डू द प्रीवियस ईयर क्वेश्चंस. ओके, दैट्स वेरी इंपॉर्टेंट, बिकॉज क्वेश्चंस जो होते हैं ना वो बहुत ज़्यादा डिफरेंस नहीं होता. द नंबर ऑफ स्टेप्स वी नीड टू टेक, द अप्रोच, द फॉर्मूले वी रिक्वायर, ओके, one exact idea you will get, and that's too very accurate when you are doing the previous year questions. उससे ज़्यादा बेस्ट आपको किसी भी एग्ज़ाम की प्रिपरेशन आप करते हैं ना, तो उस एग्ज़ाम की प्रीवियस ईयर क्वेश्चंस आपको सबसे ज़्यादा अच्छा आइडिया प्रोवाइड करते हैं, द लेवल एंड व्हाट यू नीड एग्जैक्टली एंड एवरीथिंग. बहुत इंपॉर्टेंट है. क्लियर? वेरी गुड कीर्ति, वेरी गुड पवनीत, वेरी गुड शोभना, वेरी गुड रिया, वेरी गुड सुधा, वेरी गुड सीमा, उदयभजनी, वंदना, सुब्रमण्यम, रामचंद्र, माली, एंड व्हाट अबाउट अदर्स? What about others? I'm still waiting for more answers. If you will have any doubt, we'll discuss it. If it is clear to everyone, we'll talk about the next question. Very good, Pradeep. And guys, if you are not on the Telegram channel Mission Net Physics Exam, you can join that channel to know about the upcoming live sessions, special classes, YouTube sessions, to get to know about them earlier so that you will not miss any of the sessions. So you can join the Telegram channel Mission Net Physics Exam. Saddam, I will discuss. Okay, very good, Anirban. Subramanyam, here is the poll. Please select your option A, B, C or D. Whatever is correct, you can select it. I'm just going to see your answer. Yeah, I can see you have selected option D. That's good. Okay, now if we are going to talk about the question, yes Mali, I'm going to consider it. So guys, let's consider this question and let's talk about it. What are the steps you have to take to solve this question? Very good, Pradeep. Yeah, that's good. Now if we are going to talk about this question, let's read it once, then let's proceed further to select or to get the right answer. Done? हाँ कीर्ति, यू नीड टॉफ़ी. ठीक है, नेक्स्ट क्वेश्चन में टॉफ़ी मिलेगी. इफ वी आर गोइंग टू टॉक अबाउट दिस क्वेश्चन, द क्वेश्चन इज a mechanical system is described by the Hamiltonian H, which is a Hamiltonian corresponding to old set of coordinates small q and small p, as a result of the canonical transformation generated by f, which is a function of small q and capital Q, okay, and that's equal to minus capital Q upon Q. The generating function is given, the Hamiltonian is given corresponding to old set of coordinates. Okay, after that what we need to do, the Hamiltonian in the new coordinate we need to find. The Hamiltonian in the new coordinates capital Q and capital P becomes what? That's what we need to find. Clear? Very good, Preeti, very good, Deepak. Now let's consider it. See guys, in this case, if you know the Hamiltonian corresponding to old set of coordinates, and if you want to find the Hamiltonian corresponding to new set of coordinates, you know the formula, that is h dash is equal to h plus delta f upon delta t. F is the generating function, this delta is the partial differentiation symbol. Okay, h is the Hamiltonian corresponding to old set of coordinates, h dash is the Hamiltonian corresponding to new set of coordinates. What is f here? F is the generating function which is given like this. Is this a function of time? No, it's not a function of time. That means here we will be able to get h dash is equal to h. Why? Because the partial differentiation of generating function with respect to time will be equal to 0, as the generating function is not a function of time. Now next thing, we know Hamiltonian is equal to what? P square upon 2m. P square upon 2m. This is same as the previous question, but I think the generating function is different. Plus 1 upon 2 m omega square q square plus 1 upon 2 m omega square q square. Next thing, what is the generating function? That is minus q upon q, minus capital Q upon q. Clear? Now next thing, if we are going to talk about the values of small p and small q, which we have to write in terms of capital Q and capital P. But why we need to write them? Because we want to find the Hamiltonian corresponding to new set of coordinates. Okay, that's why it's important to mention or to get the expressions of small p and small q in terms of capital Q and capital P. Now for that we will use the formula corresponding to generating functions. Here the generating function which is given to us, that is a function of capital Q and small q. What is not present here? Small p not present as well as capital P not present. Small p formula will be what? That's going to be delta f upon delta q. What about capital P? That's minus delta f upon delta capital Q. Now let's put the value of f here and we will get q upon q square. Okay, when we will just get this relation. Also capital P we will get as minus 1 upon small q, and small q will be equal to minus 1 upon, oh, it's not minus, it will become plus. Why? Because one minus sign is here, another here, so it will become plus. So it's going to be q is equal to 1 upon capital P. That means when I will put the value of q here, that's 1 upon capital P, I will get it as q into p square. That is the value of small p. And this is the value of small q. Okay, that's how we are going to get. Just put these values back in this relation, what you will get. When I am going to consider h dash expression, I will get q square p to the power 4, because small p is qp square. So when I am going to put it here, I am going to get this relation plus half m omega square, okay, small q square. What is q square? That's 1 upon p square. P square 1 upon p square, that means I can write it as p to the power minus 2. That's how we are going to get it. Is this clear to everyone? And that's your final answer. That is the value of h dash. Q square p to the power 4 upon 2m. Observe the option D. Plus m omega square upon 2 into p to the power minus 2. That's it. This is how you are going to get the Hamiltonian corresponding to new set of coordinates. Option D is correct. I hope it's clear, but if there is any doubt, you can let me know. And if it is clear, let's talk about the next question now. Can we talk about next one? Excuse me. You want the homework question? Okay, as you wish. The Hamiltonian of a simple pendulum. That is p theta square. Theta is in the suffix of p. Okay, that is the the linear momentum corresponding to the coordinate theta, p theta square. The value of I will write the options on the next slide, or I can write it here as well. Okay, let's try to complete it on the same slide. Guys, you want to solve it right now, or you will do it in the homework? You want to solve it right now, or you will do it in the homework? Very good, Saddam. Very good, Riya. Very good, Devajani. Very good, Shobna. Okay, try it and let me know if there will be any doubt. Also, guys, note down the parameters given in the question. Okay, then you can start solving it. Very good, Harinder. Very good, Ali Priyo. Very good, Vandana. Very good, Kirti. Very good, Seema. Very good, Mali. Very good, Pradeep. Firan, I will discuss it. Okay, you are saying how we know that in which question we use the short trick. So for that, to know this, that where you can use the trick, there is a trick. The trick is whenever you can simplify, easily you can separate out the terms given in the Lagrangian or Hamiltonian, the kinetic energy term and the potential energy term. If it is possible for you to identify them separately, then you can use the trick there. But if there is any confusion, any doubt regarding those values, you will not go for the trick. But whenever it is possible to separate out the kinetic energy and the potential energy terms, you can use the trick. Saddam, right now you can start solving it. Very good, Sayada. Mali, I will discuss. Very good, Karishma. Done. Yeah, in this you can use the trick. That's very good, Pradeep. Okay guys, I hope till now you all have noted down the question. I will start the discussion about this question. Till then you all will try, those who have not solved it yet. Then I will start the discussion about it. Okay, so I'm giving you time to solve it. Guys, if you want to attend the more regular live classes by the top educators we are having on Unacademy Plus for your upcoming CSIR Net Physics exam preparation, so you can take the Unacademy Plus subscription. Also, by using and by applying the referral code, that is Anjali Arora, you will get the 10% discount in the total Unacademy Plus subscription amount. So after taking the subscription, you will get so many benefits, like weekly quizzes will be there, doubt clearing sessions will be there, mock test will be there, PDF of important notes will be available to you, and you will be able to attend the live classes by all the top educators we are having on Unacademy Plus for your upcoming CSIR Net Physics exam preparation. So in all these ways, the Unacademy Plus subscription will help you to do the best preparation for your upcoming exam. Also, you will get very clear idea about the topics, the concepts, the tricks, that what are these things, the concepts, topics and tricks for your upcoming CSIR net physics exam, which will help you a lot to solve most of the questions in the exam, to maintain a good rank, to score good marks. So if you want the guidance by all the top educators, you can take the Unacademy Plus subscription. Also, wherever you will take the subscription, use and apply the referral code, that is Anjali Arora. As you can see, I have already mentioned it here. So no space in between, spelling should be same. That's how you need to write, and you need to apply this referral code. By using and by applying the referral code, you will get the 10% discount in the total Unacademy Plus subscription amount. And this will surely help you a lot to do the best preparation for your upcoming CSIR net physics exam with the guidance of all the top educators we are having on Unacademy Plus for your upcoming exam preparation. Let's continue the question now. Okay, most of you want me to discuss it, so let's just start the discussion about this question. Very good, Subramaniam. See guys, in this question, can we say this is kinetic energy term and this is potential energy term? Also, we know Hamiltonian in general is T plus V. That means kinetic energy plus potential energy. So if I am going to talk about the Hamiltonian, okay, in this it is possible for us to compare kinetic energy and the potential energy terms. So if I want to write the Lagrangian directly, how I can write it? I know Lagrangian is a function of generalized coordinate and velocity. So half mv square, p square upon 2m. What is the value of m I am getting? ml square. So half mv square, that means in place of m I need to write ml square. Okay, and v square means what? Theta dot square in this case. Clear? Next thing, if I am going to talk about the next point, that is minus L is equal to T minus V. V is what? V is this potential energy expression, which is mgl 1 minus cos theta. This short trick I have told you in the previous classes recently, like regular we had the classical mechanics session here. So I have discussed this trick. Okay, the trick we are applying here. Now the point is we need to get the total time derivative of Lagrangian. I have even told you this formula, that anytime if you want to get the total time derivative of any variable, then you need to write its Poisson bracket with Hamiltonian plus del L over del T in this case, that is its partial differentiation with respect to time. But Lagrangian, is it a function of time directly? No. So partial differentiation of Lagrangian with respect to time will be what? It will be 0. That means I just need to solve the first part, that is a Poisson bracket of Lagrangian with Hamiltonian. So we know here what is the coordinate involved, that is theta. So it will be del L over del theta and del H over del P theta, and minus del L over del P theta and del H over del theta. Now the point is, if you will directly see del L over del theta, what is that you will get? You are just going to get minus mgl, 1 minus cos theta is already here. So you will get plus mgl cos theta. What is the differentiation of cos theta? That is minus sin theta. Done. So you will be able to get minus mgl sin theta for the first term. Minus mgl sin theta. What about del h over del p theta? Del h over del p theta will give you 2 p theta upon 2 ml square. 2 cancelled out, p theta upon ml square. You are getting p theta upon ml square. Done. Minus del L over del P theta. If you will directly observe it, there is no P theta term present. But is there any formula we know which can provide us the relation between the theta dot and P theta? Yes, there is a relation. What is that? That is even for Lagrangian and Hamiltonian, for both we are having. If we want to get that relation for the Hamiltonian, we know Hamilton's equation of motion. So what is that Hamilton equation of motion? We are having the relation, that is we want to get the theta dot in terms of p theta now. So it's theta dot is equal to del h over del p theta. Theta dot is equal to del h over del p theta. That is what? That is the Hamilton's first equation of motion. Clear? Now in this case, if I am going to talk about this expression, what I will get? I am going to get theta dot is equal to p theta upon ml square. Done. Now p theta will be equal to what from here? That will be theta dot into ml square. And what about theta dot? P theta upon ml square. So here in place of theta dot, if I am going to put p theta upon ml square, okay, and it's a square too. Why? Because it is theta dot square. So p theta square upon ml square whole square. Ml square will get cancelled out. We will just get p theta square upon ml square. okay, p theta square upon 2 ml square. So that when I'm going to differentiate with respect to p theta, what I will get? I will just get 2 p theta upon 2 ml square. So p theta upon ml square after differentiation. P theta upon ml square. So that means if you know some relation, if you know something that, oh, this is the relation between p theta and theta dot, and it is possible for you to convert that p theta into theta dot or theta dot into p theta. So you will do that conversion and then differentiate. If you will differentiate it directly, you will get it 0. That's not okay. Okay, and mostly in this question, students make the mistake that they don't consider this expression of p theta or theta dot in terms of p theta, whatever is required. Okay, delta h upon del theta, what you will get from here? That's gonna be minus sine theta, and minus sign is already here, so it will become plus. So plus mgl sine theta. It's gonna be just mgl sine theta. Done. Let's simplify it. This is also negative, this is also negative. The expressions are exactly same. When we will just simplify it, we will get twice of that. 2 mgl sine theta p theta upon ml square. LL you can cancel it out. This power 2 will get removed. This will get removed. You will get and also m will get simplified. So you are just going to get minus 2j upon L sine theta p theta. That's how you will solve it. Clear? And that's how the option A will be correct option. Clear? I hope it will be clear to all of you now. Thank you so much everyone for joining this session. Now next week on Monday, Tuesday, Wednesday we can have this session. Okay, I will even provide you the updates about it in the Telegram channel Mission Net Physics Exam, and if you are not there, you can join that Telegram channel Mission Net Physics Exam, because there I keep on providing you the updates about the upcoming sessions. So don't miss those updates, and don't miss the sessions too. Thank you very much everyone for joining this session. Subramaniam, it depends on problem, because the given question. Why? Because here we need to differentiate, so we need to convert that value. If we don't need to differentiate, we will not do that. And in general, Lagrangian is a function of generalized coordinate and generalized velocity. You keep it in that terms. Also, Hamiltonian is a function of generalized coordinate and generalized momentum. So you keep it in these terms in general, but if needed somewhere, you can do the conversion. You know the conversion formula. Clear? Thank you so much everyone for joining this session. Yes, Pradeep. Also stay connected on the Telegram channel Mission Net Physics Exam for any new updates. Clear? Also guys, whenever you are going to take the Unacademy Plus subscription for preparing for your upcoming CSIR Net Physics exam, you can take the Unacademy Plus subscription for that to attend more regular live classes by all the top educators on Unacademy Plus for your upcoming exam preparation. And by using and by applying the referral code AnjaliARoora, as I have mentioned it here, no space in between, write it, apply it, and get the 10% discount in the total Unacademy Plus subscription amount. Clear? Thank you so much everyone for joining this session. Mali, Unacademy Plus पर मोस्टली रेगुलर क्लासेस होती हैं, एक दिन में कभी 2, कभी इवन जैसे आज मॉर्निंग में थी 11 बजे, फिर 1 बजे, फिर अभी है 5:30 बजे. ठीक है, सो एट 5:30. तो अलग अलग टाइम पे, कभी मतलब अलग अलग डेज का अलग अलग स्केड्यूल होता है, बट नॉर्मली वीक डेज में रेगुलर रहती हैं. ठीक है, और स्पेशल क्लासेस for them I will provide you the updates guys. As I have told you, stay connected on the Telegram channel as well, so that you will not miss any of the sessions. Most probably our next month special classes will start on 3rd August. ठीक है, तो मैं आपको वो लिंक प्रोवाइड भी कर दूंगी, डिस्क्रिप्शन में भी आपको मिल जाएंगे. और थैंक यू सो मच एवरीवन फॉर ज्वाइनिंग दिस सेशन. हाँ, वंदना आज नहीं है. Clear? And guys, next month our 6 o'clock special class timing may get changed. ठीक है, क्योंकि next month के लिए कुछ और टाइम हो सकता है. Updates you will get about it on the Telegram channel Mission Net Physics Exam. Okay, so don't worry about it. And thank you so much everyone for joining this session. Thank you, thank you, thank you. And whenever you will take the Unacademy Plus subscription, you can use and apply the referral code, that is AnjaliARoora. Okay, spelling should be same, no space in between, and apply it and get the 10% discount in the total Unacademy Plus subscription amount. Thank you everyone.